So I'm an engineer by trade. I'm currently a product leader at New Relic. Spend a bunch of time building tools to help people make the web faster. Have never actually worked on a website before where I was the operator trying to deliver content to end users. And so one of the things that I'm always humbled by in my role in product management is getting to meet with folks who are actually out there every single day trying to solve the hard problems that get in the way of people and good user experiences. But you know, over the years I've worked on synthetic monitoring products and run products and all these different things. Most of that time in engineering and product management. A little bit of a chunk of it, though, I actually spent in sales, which, how many folks in the room, just out of curiosity, have ever held a sales type of role before? Oh, wow, yeah, a handful. And then how about how many people have held some sort of a marketing type of role before? Cool. So, you know, the little bit of time that I spent in that role was, I thought one of the things that surprised me was how much I learned about web performance as a result of actually spending time in sales and shattering some of the preconceived notions and things that I had about how sales works, and starting to learn in the process how much trying to optimize a website and working in engineering and all of those things actually have in common with our friends over on the sales side of the house. And for me, I think it starts with thinking about how things actually get sold in the first place. And so this is an oversimplification, and it's sort of narrowed to a specific type of sales, which is enterprise software. But for the sake of setting up the conversation that I wanted to have today, I wanted to spend a little bit of time just going through this and then talking about how it relates to some other things having to do with performance budgets. And so, you know, there's this thing where people dump into the top of the funnel. Usually that's, you know, people don't just show up to buy a product. You have to do work to get them to develop that interest and that demand in the first place. So in the sort of traditional old school way of doing that, it involves a lot of outbound activity. So you're firing off all these emails, making all these phone calls, and, you know, a lot of those times people don't answer the phone, they trash the emails, and so a lot of people fall out of the funnel at that step. So it moves on to the next one. A percentage of people do, and they take some level of interest in whatever it is that you have to offer, and so that turns into some sort of an initial call. Some folks will listen to the initial call, and they'll say, nope, this isn't for me. Others will say, this is interesting enough for me to commit another hour or so of my life for you to show me what the product actually does, and that leads to a demo. Again, some folks will see the demo, nope, not for me. Others will want to try it out with their own data instead of just canned, you know, data that was part of the demo. And so they'll embark typically in the enterprise software type of segment, some sort of proof of concept where they can try it out for some prescribed period of time. And if they like the trial and it solves a meaningful problem for them, then that results in some sort of a proposal. And then, you know, something happens that is the most important thing that can happen in sales. It's the two sweetest words that exist in the English language for someone in sales, and it's closed won. That's what the opportunity is called at the point where the sale has actually been made. And the reason why closed won is so important, so critical for sales professionals and also for the business as a whole is because there are all these good things that flow, crucial things that flow from those closed won opportunities. For the business, it means bookings and revenue, metrics that you know, investors and the street and everyone is tracking extremely closely as a gauge of the overall health of the business, for better or for worse. The other thing is the revenue and ultimately the cash that comes from that is what pays all of our salaries. So it's really important. And then for the sales rep, it's even more important because half of the actual cash that they make in a typical sales comp plan is actually directly coming from the commission on those sales. And so it's a really important thing, all of the metrics that are associated with tracking the movement through this funnel and the conversion of products from value propositions into actual revenue are tracked very closely. And actually, as a result of that, there's a very large company that has a $124 billion market cap and I think the tallest building in San Francisco that's devoted to collecting metrics and doing analytics to help people understand how people are moving through the funnel, where things are getting hung up, and what someone can do to solve those problems. And so in service of providing those analytics to companies, you get all these reports that people generate out of Salesforce. And so there are all these different types of questions that you can ask of the data, and then the software will give you all of these different answers back. So I can see, for example, the average number of calls that my reps are making each week, that top of the funnel activity. The other thing that I can see is how many POCs were started. You know, I can segment the proposals that are out there by the total number of bookings, so I can see clusters of activity for the business, and I can see who sent the most emails this week. If I'm a people manager and I have someone I want to see track the activity of all of my individual reports, I can do that through analytics software like what Salesforce provides. I can see what percentage of demos convert, all that stuff, right? I mean, I can load myself up, and most companies do. If you ever have a Salesforce account, sometime you should log in. It's a freaking mess at most places of reports and dashboards and all these different things that people have created. But all of it is in service of this one thing, and it's creating more of those closed-won opportunities. And so, you know, if you imagine a world where folks were asking all of these types of questions, but the reports and the data and the dashboards didn't link in any meaningful way to generating more bookings and more revenue and more closed-won opportunities, then you would look at that and you would say, wow, that's an exercise in absolute pointlessness. Why are you generating all of these reports about how many people are making phone calls if you don't know the outcome that it's actually going to produce for your business? And so what I would like to propose to everyone to think about today is consider that in web performance, we do exactly what I was just talking about, something you would never do over on the sales side. So more often than not, we're generating lots of metrics, lots of reports. There's tons of open source tools, lots of vendors like, you know, the ones that I've worked for over the course of my entire career, where we give you lots of different ways to understand at the metric level information about third parties, information about the size of large assets that are on the page, helping you track longitudinally over time summary statistics like median for segments like mobile devices. You know, and even getting down to the minutia of the millions of different URLs that you probably have on your website. What are the 10 that are the slowest? And all of that different type of stuff. The problem is that without putting all of that in any kind of a meaningful context, then it's really hard, and this has been talked about and some really interesting points of view that have been offered by other speakers, both earlier today as well as yesterday. It's hard to get external buy-in from stakeholders that are outside of this audience that are already sold on performance. And so what I would also submit to you is that the way you get that external buy-in is to create the linkage between the technical metrics that you're collecting and the actual business outcomes, so that you can go to somebody and have these conversations that aren't just about, wow, I've got lots of problems with third-party or JavaScript execution or whatever all of this stuff is, but you can complete the sentence and say, and it's driving customers away, so, you know, we're not selling as many subscriptions to our website, or, you know, it's hurting us, abandonment is dropping people out of the cart, or whatever it is that drives, you know, the health and the revenue of your overall organization. And so when we think about, okay, well, what does that mean at an abstract level? Okay, great, I need to create this linkage between the technical metrics that, you know, are my area of expertise as an engineer who's focused on web performance or whatever my performance role is, and the business outcome. How do I get started? What I propose to everyone today is that it starts with a really simple step, and that is making sure that you measure business and technical metrics together. And so it's not enough just to collect the technical metrics. You also have to collect some other contextual information about how those technical metrics are affecting the behaviors of the people that are moving through the website. And so a way that you can tell, that you could test yourself, if you're successful in your organization at doing this, is to ask yourself the question, when you're trying to get people focused on performance, are you telling them that faster is better? Or are you getting more specific than that and telling them how much faster and how much better? And there are ways to do that using data and analytics. And to be honest, it doesn't take much adding on to systems that you're probably already doing today in order to track performance. And so the way that I break it down in my own head is to put it in a three-step process. The first step is to identify a hero metric. And we'll talk a little bit more about this next, but this used to not be an issue because we were very limited in terms of the metrics that we could actually measure. Now we're spoiled for choice. There's tons of metrics that we can measure, so we have to figure out which one we actually want to focus on. The next one is to tie the value of that metric to a specific business outcome that motivates all of the stakeholders within your organization to take action. And then the final one is to, after you've extracted a performance budget from that, use the performance budget to go find all of the slow experiences that are violating it, and then drill down and figure out what went wrong. And so the first step is to identify a hero metric. This is Sky from Paw Patrol. She's a hero. It's my daughter's favorite hero. We're spoiled for choice, like I said before. And originally, back in the day, onload was basically, especially if we're talking about real user monitoring, about the only way to do this. The most popular open source framework for collecting run data, Boomerang, when it got started as an extract from the way that Yahoo was doing real user monitoring, it had this notion of when the page was done, it would default to onload. The way that it would track onload, you couldn't even ask the browser how long it took for a page to load. You had to hack it by setting an unload cookie, or setting a cookie in the page on unload with the current timestamp, grabbing a timestamp when the next load event happened, and then subtracting the two, which of course means that you have no idea how long probably the most important page took to load, which is the first one. The best you could do was approximate by setting a timer from the top of the page to the bottom. Now, there's a lot more you can do, right? So navigation timing came out. You've got this litany of metrics you can get at the page level. There are resource timing metrics from which you can deduce all sorts of things. User timing, where you can customize stuff. Paint timing, has been spec'd and it's on its way out into browsers. So there's this long list. I put a few of them up here. I'm sure you could double that list if we all sat down and talked about it. Similarly, I found this on this really awesome Successories poster that I got off the internet. There's a number of business metrics that are common ones that you find when you talk to people about what performance means for them outside of engineering circles. And so you'll hear things like bounce rate and conversion rate, cart value. There are all of these different metrics. And by the way, people do collect this information already. And everyone here, I'm sure, knows that, but it's collected in a different place. It's collected in all of these marketing analytics packages that have a lot of visibility into what's happening on the behavioral side, but very little, if any, visibility into what's happening on the performance side. And so the value that we can bring to the organization is to tie that together by measuring both of those things together at the visit level. And so, in your RUM metrics that you're collecting, you can do this with open source RUM providers. You can do this, I believe, with most of the commercial ones too, where you want to make sure that as users are moving through the page, you're collecting the business metrics and then coalescing them before you do the analysis back into visits. Visits, I think, are really key to extracting performance budgets because the visit level is where you actually get the user story. That's the analysis of everything that the user did and how the performance affected their behavior, not just a snapshot of one page in what might have been 20 different interactions on the site. So if you imagine, for example, I know some tools will just dump all of this stuff out at the page level. You would just need to pull all of this into some data analysis tool. I did some experiments that I'll walk through in a minute using Python. And then you can just coalesce them all back together as long as you have a session ID. Now that we've got all this data, the next thing to do is to start to refine what we're actually looking at and narrow things down, because that row is going to be a really wide one. It could easily have 50 or 100 different attributes on every single one of these visits when you sum up the technical metrics and the business metrics. So the first step, I think, it's actually a social step where you get all the stakeholders in the room and you lay out all of the different business metrics that you could track and say, which one is the one that is most important to us collectively as a group? There might be 2 or 3, but I suggest really pushing on this and trying to get people to commit, at least through consent, if not consensus, that they'll focus on this one thing at least first to get started, because you can make this an iterative process and you can change as you go. But I submit that you should narrow it down to one, like conversion rate or bounce rate or session length, before you move on to looking at the technical metrics. So then once you've got the business metric nailed down, we can use that as a tool to evaluate which of the litany of technical metrics should actually be our hero metric. And the way that we do that is by looking at how the value of the business metric changes correlated against changes in the value of the technical metric. And I'm sure everyone's seen these charts before where you see the bounce rate plotted and it goes up and to the right. The slower the experiences are, the more it's driving traffic away. Similarly with conversion rate, it tends to go down and to the right, where the slower the site is, the more people are dropping out of the funnel and the less likely there are to buy. One of the things that I've tried before is taking that chart and then just doing it iteratively through every one of my candidate metrics and looking at the slope of the curves and trying to find the ones where the line takes off the fastest, meaning little changes in performance have the most outsized change in the value of the business metric, and using that as a filter for narrowing down on what the hero metric was. One of the things that I started doing in some of my spare time, though, over the last year is learning a little bit about data science and machine learning. I've got Pat Meenan, who I think is in the room here somewhere, and also Tammy Everts of Speed Curve to thank for that, because they did a really cool presentation. They actually did it twice at a couple of performance conferences a couple of years ago, where they took a bunch of RUM data in aggregate and looked for trends that might hint you as to which of these metrics are the most important and best candidates for hero metrics. Now, it sounded really complicated, and I'm definitely not a data scientist. I'm not even a Python developer, so I had to learn Python first. But the thing that struck me about this was it actually wasn't that difficult to get myself up to speed on using Python in some of these libraries, because they're just kind of pre-baked for you. And so the first one, the one that I would recommend to get started, is this random forest classifier. You can go on the scikit-learn website and read all about it. There are a few things about random forest classifiers that I think are useful for creating machine learning models that help us figure out which technical metrics are most predictive of the business metric. One of them is that the random forest classifier, after you generate your model and you train it on a training data set, and then you test it on a test data set, and you decide that you've created a model that's accurate enough to be useful, unlike certain other things like deep neural networks, you can actually ask the random forest classifier to give you the relative importances of all of the different features that it was given. So that basically gives you the model's view of a stack rank of which of the features were most useful in predicting whether or not the metric was going to take the value that you wanted. So in this example, what I did was I took a bunch of RUM data with a bunch of technical metric information. So we've got front-end time and DOM complete. Over here is the onload event. So as we can see in the model, that was not the most important one. Time to first byte, connection latency, DNS, and the other ones. Put it all into the model and said, use all of this information to predict whether this visit is going to be a bounce or not. And so after it built the model and did all the stuff and tested it and made sure the accuracy was high enough, I could go in and say, okay, give this back to me and tell me what the hero metric should be. And it turns out in this case, it's front-end time. Now, the data that I had available in this data set didn't include some of the modern metrics that are out there now. So imagine what this might look like if you included some of the render metrics and other paint timing things that are in there. I think it'd be really interesting. And it's actually not very hard to do. Now, there are a few considerations for random forest classifiers. One of the things that I also like about it is, and again, it goes back to the whole thing about I'm not a data scientist, is I don't have to apply a lot of expertise to train and tune and modify the model to get it to work correctly. One of the things that my understanding is it does really well is it handles unbalanced data well. So you think about bounces versus non-bounces. If the overwhelming majority of your traffic bounced, then a lot of models will have difficulty, or a lot of algorithms will have difficulty building a useful model, because they'll just default to guessing that it's going to bounce all the time, since most of the time it did, and it'll be right most of the time. Random forest classifiers handle the unbalanced data sets pretty well. The other thing about, it doesn't require as much tuning as other methods, like I mentioned. There are hours and hours and hours of fascinating content on YouTube about how to tune deep neural networks, and I didn't have the time to do that. I wanted to get a useful result quickly, and so random forest classifiers were a quicker way to do that. The big one was number 3, that it will actually tell you something about itself. It's not completely opaque about how it made the decisions that it made. And the point here, which is counter to the use cases for a lot of machine learning models, is we're not trying to build a model that we're going to apply to make decisions later. We're not actually going to use the model to make any decisions at all. We're only building the model because we want to learn from it what it found out about the attributes that were most useful in making predictions. because we're going to work on those attributes in real life, and the only model that we care about is the real user model, the actual people that are going to move through the site after we make the enhancements. Now, one thing that I would say is you do have to watch out for metrics that aren't collected broadly. So for example, I had a data set that I was looking at that included start render that's only available in Chrome. So when I looked at it in a data set that consisted of data across lots and lots of browsers, a lot of those start render values were 0, and as a result, the importance of that was like all the way at the end. It wasn't considered important at all. It just wasn't very useful in the model. But when I filtered the data to only consider data that actually included a valid value for that metric, all of a sudden it shot up and was extremely useful, which is what you would intuitively think, right? That start render would be something that would be very predictive of whether a user was going to bounce or not. So you have to watch out for that. You have to watch out for the whether the data is actually present or not. In this case, again, a caveat there is after I filtered it, I ended up in the situation where now my data set consists of all Chrome data. You'll have to decide for yourself whether that's useful to you or not. What I would submit is that since we're talking about user behavior, I don't think, as a hypothesis, that users who are on Edge are going to behave that differently from users who are on Chrome or on Safari. And so I still think it's a valid test, but you'll have to try it out and see for yourself. But what's interesting about it is it's a way to stop the sort of subjective bickering around what should be the most important hero metric and narrow it down to focus on one thing. That's not to say that the algorithm just kicks out a value that you should blindly accept. There's still a human sort of editorial process. You have to look at it and make sure that it makes sense for you. But I think it helps you get a lot faster to some level of consensus of what the metric should be that you actually want to optimize. So great. Now we've got our hero metric. Now what are we going to do? Now what we want to do is we want to tie the performance budget that comes out of that to some sort of a business outcome. How do we get the performance budget? So this is, again, one of those charts that I think people have seen before a lot. There is an extra detail on here, however, that is important. The blue line is the way that most of these bounce rate charts get rendered. So it's taking every single point on that line is a slice, and it consists of only those users who had exactly that load time, and then the Y value is exactly what the bounce rate was for that cohort. And so the dotted red line is what the overall bounce rate was for the entire population. So that's why the bounce rate line shoots up above the overall dotted red line, is because you're looking at tiny little cohorts that actually did experience bounce rates just within those tiny little slices that were higher than the total for the entire population. This is the way that most of the bounce rate charts work, most of the conversion rate charts. What I would suggest for y'all when you're considering how to generate your performance budgets is that you look at the data in a slightly different way and use a cumulative distribution function. And that's what the orange line is, the curvy one there. What that's doing is when you index along the x-axis and you pick a value of that line, what it's telling you isn't just what the bounce rate was for the people who got exactly that load time. It's telling you something that's slightly different, but it's important. It's that's the bounce rate for everyone who got that speed or faster. And so when you think about how do we define performance budgets, a performance budget of 3.5 seconds doesn't mean we want everyone to get exactly 3.5 seconds as the value of the metric. We want it to be that value or faster. And so when we're thinking about how to visualize it and tie to a business outcome, I think it's an important consideration to make is to use a CDF type of a plot. It's not that hard to do using Python and Jupyter. I mean, if I can figure it out, I'm sure anybody can figure it out. I also have some sample code that I'll link to at the end. Okay, great. So we're going to derive the performance budget essentially from that chart. So let's say, I think in our previous example, we had like a front-end time that was going to be our hero metric. What I would recommend is that you don't do, the tendency is to go find the absolute best value and say like that right there should be the performance budget. My suggestion is that you make it an iterative process. And so pick a modest budget value and then work at it, chip away at it, make it faster and faster. So that's what this view does. What we basically did is it's that chart more or less, just the CDF part of it that we were looking at just a minute ago. But there's a left side and a right side. And the x scales of those are not equal. So the you can't, I don't know if you can see it very well, but the X scale on the right side actually goes out far, far longer than it appears. It's compressed down because that's the long tail of the distribution of all of the slow experiences. And on the left side is the faster one. Now all this chart is doing is it just drew a great big green line right where a 10% improvement of bounce rate would be. And then it kicks out, and you can see here up at the top on the left, it says the budget should be 5,370 milliseconds. So that's not too impressive, is it, right? 5.3 seconds as a target that we're trying to hit is not like the 2 seconds or the 3 seconds that we read about all the time. And again, I think this goes back to the building the culture of performance and setting realistic expectations. If you're operating a site where a 10% improvement actually results in this type of a load time, then I suggest that you start there and then just chip along, because you're going to need a lot of people to work together to help you actually make the site faster. And having a framework in place where you can visit and revisit and keep people in the conversation is as important as the actual technical answers to the questions and the work that needs to be done. So what we see here, what the chart's telling us, is that a 10% improvement in bounce rate for this site would be 13.62%. In order to do that, we would need to get all of the visits that are slower than 5.37 seconds underneath the budget, and that's the business benefit. And so the budget that nets out of it is the value shown. That's looking at the entire user population. Something that I would encourage everyone to do is to consider pausing here and then running this analysis, segmenting it by different user populations. Sometimes we see that folks have different levels of tolerance for performance when they're using mobile devices versus desktop devices, or when they're in one country versus another. Another consideration to make, and this goes back to actually the very first talk with Kirtana at the beginning of the day yesterday, talking about countries where you may not currently have a lot of traffic, but you're getting ready to because they're exploding in terms of internet access. If you look and you see that currently you've got really slow load times in India, but it represents a tiny segment of your population, it's easy if you're just taking a broad view to not consider that you might want to carve out a special budget and special time to improve specifically in India. That's again one of those areas where the computer's not going to do all the work for you. You have to actually think strategically as well and say, do I want to focus efforts and create budgets in certain areas where perhaps I don't have users today? So that would be a blind spot if I were only looking backward at the data that I've collected to date, and consider that I want to actually prepare and be ready for when that traffic shows up. Back to the small improvements thing. So what we're going to do is pick a modest improvement and then try to chip away against that, and then reset the bar, and then reset the bar, and then reset the bar, and it helps create that culture of performance. So once we've narrowed down to the hero metric, we've tied the hero metric to an outcome that's meaningful to people, we've used a desired value of the business outcome to extract the value of the technical metric, the next thing to do is to actually start working on solving problems where users are getting experiences that are slower than our budget. And this is an area where I think we make things harder for ourselves than we need to sometimes, and a lot of it has to do with the standard tooling that's out there. Because most of the ways that people collect metrics about performance on websites is actually perhaps not designed for the use case of optimizing the performance of your site. Something else I'd submit to everyone to consider is that there's a difference between monitoring your site and optimizing your site. Most of the tools that are out there today are all about monitoring the site. So what do? They say pick a percentile or a summary metric like average or median or P95 and fix the percentile in place and then watch for changes in the value, right? And so as the median moves up or the median moves down, you're going to track it in a time series chart. There's alerting that comes along with that with most tools, right? So if the median or the 95th percentile shoots up to a value I'm not happy with, then alert me to it. But that's not the way that the performance budgets work, right? What performance budgets want you to do is not fix the percentile, but to actually fix the value instead. And then we're going to try to get as many users as possible to come in under budget. So it's actually a reversal of the way that most people typically think about using their tools to analyze performance data. And so what that leads to is this situation where you've got all of your good experiences, the ones that are already below budget, and they're already mixed in with all of your bad experiences that you wanted to focus on, and it's really confusing to figure out where the bad experiences are. It's like hunting for Waldo in a big giant sea of non-Waldos. So that's why I think it's important to, after you've defined your budget, as you move into the optimization phase, to go in and get all that, the green area that was on that chart from before, sweep all that stuff up and get it out of your data set that you're analyzing, and only look at the visits that were actually what you're defining as poor user experiences. So there's lots of ways to do this. Single dimension analyses are probably the most popular way that people do. You'll notice that this box is only red. There's no mix of green and red because, like I said before, we already got rid of the green ones. This is just the ones that were over budget. So what I can go through is look for, I want to find clusters of experiences along some dimension that were both really poor, so really slow, and it impacted a lot of people. So it's not enough to just, if all I'm looking for is slow only, I will very quickly get a list of cohorts that have exactly one person all the way down the long tail. That's not the most useful use of time to go optimize. Similarly, if I look for the ones that just have the most users in it, I'll get very predictable metrics, right? So like, for example, the largest cohort for a US-based site is going to be US, just in terms of visitors, by definition. That's not useful at all. So what I need is some kind of a ranking that's taking into account both of those variables, the degree of the badness of the user experience and the size of the population that was impacted. So tree maps as a visualization are a good way to do that. You're basically looking for big red boxes. But something that I think is perhaps a little faster way to do this is to do the ranking by multiple factors and then to include all the different cohorts. So there's some sample code that I put online in crummy Python code that probably everybody will look at and optimize because it's terrible. But it did seem to work for the test sets that I tried. And all I did was I took all of that typical single dimension analysis, and I did it by like country, by the type of the page, by the user agent, by the device type. And since we're talking about computers here that have lots of RAM, I just threw them all into a big bucket and then said, go look at all of them and then rank them on an XY axis, where the x-axis is the percentage of the total population that was impacted, and the y-axis, I had to use a summary statistic in this case, so I went with the median value. So the ones that are up and to the right, again, like I said, this is for a site that is mostly US-based traffic, so that US dimension is not that useful to me. Again, the algorithms will never be able to just hand you everything that you need. There's always some human interpretation that's required here. So I'm going to discard that one. But I can see that there is a particular URL that looks like it both impacted a lot of people and it was slow. And then there's a particular category of pages that looks like it was really slow and it impacted a significant number of people. So in a world where there's always way, way more to fix than there's ever time to do, the intent here is to help you prioritize so you can figure out not just what to fix, but actually what to fix first. Now, it's not enough to do this as a point-in-time snapshot. It's something that you need to rebaseline and revisit quarterly for at least a couple of different reasons that I can think of. First of all, the site is going to change, so you need to rebaseline. Second of all, your users will change over time in terms of what they expect out of the website. People's expectations of performance in 2019 are not what they were in 2012. And then for the third reason was what I was talking about before. It's the idea that in order to keep focus on this, you have to have some framework in place where you can keep people engaged. And that's not a technical problem, that's a people problem. So building in a regular cadence where people are looking at this is a really, really useful way to create that focus on performance. So it really just comes back to that understanding relationships between people and between data, sets of data. You have to understand how a change in performance is actually going to change your business if you want to motivate people to actually work on performance problems. And so the step that I would ask everybody to take on, oh my God, the contrast is poor on that, when you get back to work, I'll just read it, is ask your business partners what metrics they use to define business success. And if you're not already including it in your RUM data, then make sure you're putting it in there. Like I said, whether it's open source or commercial tools, substantially all of the ones that I've seen have some form of a custom variable where you can put stuff in. So go ahead and use that opportunity to start the conversation around performance and then start collecting that data. Even if you don't have time right now to do the type of stuff that I was talking about, it'll come in handy later when you do have time and you've got months and months of nice data to take a look at. So here's some resources. They're in the slides, and I'll tweet them out on my Twitter account as well. The stuff that I did in Jupyter, which is the interactive Python environment. The random forest classifier is well documented online. I posted the example code that generated all of those charts and graphs and things just on my GitHub account, so I'll put that out there. And then the slides, which, like I said, I'll tweet. So the whole point here, I think the big takeaway, the most important meta one for me, is not just to go back and participate in a conversation about performance, but to actually lead one. So use all of the different techniques and things that you've learned from all of the really great speakers here, both yesterday and today, and use those things to start conversations about performance, collect data that helps people understand why it actually matters to them and their role and the whole company, and do that when you get back to work after the conference. Thanks a bunch for your time.